Hello everyone, I'm Frank and welcome to episode 53 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Lovely Runes by Katie Splendor, and these are pretty cool. These are very lovely runes. Anyways, here are the rules. Normal Sudoku rules apply, which means fill every row, every column, and every box with the digits 1 through 9 without repeats. And we have lovely whisper lines. Each digit along a pink lovely whisper line differs in value from its neighbor by at least 6. So as an example, if this were, say, an 8, this would have to be a 1 or 2, right? Because neighbors on this lovely whisper line have to differ by 6 or more. And the only digits that can be 6 or more away from 8 is specifically 1 and 2. And that's how lovely whisper lines work. We also have killer cages. So digits inside a killer cage are distinct and summed to the amount in the upper left corner. So you cannot have repeats in killer cages. Actually, you couldn't have repeats anyways in these killer cages because they're all in the same box, and you can't have repeats in the same box. So there's that aspect. But basically, the number in the upper left corner is what the digits in the cage sum to. So, for example, these 3 would add up to 17. These 5 would add up to 23. These 3 would add up to 12. And as an example, you could have something along, actually, let's use this 18. This could be something along the lines of, say, I don't know, 3, 6, and 9. That works because these 3 digits add up to 18, and there are all yeah, it just adds up to 18, and they're all unique. That was what I was gonna say, but you're always going to be unique in the same box, so that's not any different from normal. That's how killer cages work. And then we have crop key dots, which says black crop key dots separate digits with a value ratio of 2 to 1. And it says no negative constraints. And negative constraints usually are that specifically you can only have digits which are in a 2 to 1 ratio with where there is a black dot. But this is not using that negative constraint rule. So it's just telling us the information about the cells which the black dot is in between, right? So if this were a 4, this would have to be a 2 or an 8 to maintain a 1 to 2 ratio. And that's how crop key dots works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. So the thing is, on a lovely whisper line, the only digits that are allowed to be on it is a 1, 2, 3 or a 7, 8, 9, right? Because 4 does not have any normal Sudoku digit, which is 6 or more away, right? If you take 6 away from 4, you get -2 and less. If you add 6 to 4, you get 10 or more. And none of those are normal Sudoku digits. Same with 5 and same with 6, right? 6 subtract 6 is 0. 6 plus 6 is 12 or more, and 0 or less than 12 or more are not normal Sudoku digits. So if we have 6 cells in a box or a row or a column, which are on the lovely whisper line, that means the other cells must be 4, 5, or 6, right? Because we have 6 digits which contain 1, 2, 3, 7, 8, 9. Well, that 1, 2, 3, 7, 8, 9 must be in those 6 cells. And we see an instance like that in this box here. So this has to be 4, 5, or 6 here. And this cell is in a 1 to 2 ratio with some other digit. So this has to be 4 or 6. The 4 can be with either 2 or 8, and the 6 can only be with 3. Let's look for other instances. Do we have other instances of 6? This is 6 cells, which can only be on a lovely whisper line. So this has to be 4, 5, or 6. This has to be 4, 5, or 6. Here's only 5. This has 1, 2, 3, 4, 5, 6. So these must be 4, 5, or 6. We have 1, 2, 3, 4, 5, 6 here. So therefore, the rest in the row must be 4, 5, and 6. So this is 4, 5, 6. This is 4, 5, 6. What about this? 1, 2, 3, 4, 5, 6. So these must be 4, 5, and 6 here. This is only 5 here. This is 1, 2, 3, 4, 5, and 6. So this must be 4, 5, and 6 here. We have 6 in this column too. 1, 2, 3, 4, 5, 6. So this must be 4, 5, or 6 here. 1, 2, 3, 4, 5, 6, which means the rest of this box must contain 4, 5, or 6. And since we know we have a 4, 5, 6 triplet in row 7, the rest of the row cannot contain 4, 5, or 6. So this also must be 1, 2, 3, 7, 8, 9. And the question is, can this ever be, we have a 4, 5, 6 triplet actually in column 3, which means this cannot be 4, 5, or 6 either. So this must be 1, 2, 3, 7, 8, 9. And it's in a 1 to 2 ratio with one of these digits, and we no longer have a possibility of 4, 5, 6 in any of these cells. So all 3 of these must be 4, 5, or 6. Well, we now have a 4, 5, 6 triplet in column 1, so this cannot be 4, 5, or 6, so this must be 1, 2, 3, 7, 8, or 9. We now have 6 digits, which have to be 1, 2, 3, 7, 8, 9. So this cannot be 1, 2, 3, 7, 8, 9, so it must be 4, 5, or 6. And this 4, 5, or 6 is in a 1 to 2 ratio. Same here. Cannot be 5, because 5, if you is not double anything, and if you double 5, you get 10, which is not a valid digit. So it has to be 4 or 6. The 4 or 6 can be with, again, 4 can be with 2 and 8, and 6 can be with 3. So this is 2, 3, and 8 also. Let's see. This has to be 2 out of 4 and 5, 4, 5, and 6, and then you add a 1, 2, 3, 7, 8, or 9. Well, if this is 4, 5, this can be 9. If this is 5, 6, if it's 4, 6, this is 8. If it's 5, 6, this is 7. So this can only be 7, 8, and 9 here. This 12... Let's not go there right now. Where should we tackle then? Oh, you have a 4, 5, 6 triplet in row 9, which eliminates 4, 5, and 6 from the rest of the row, so this must be 1, 2, 3, 7, 8, 9. Well, where's the last 4, 5, or 6? Where can it be? It cannot be any of these cells because they are on the lovely whisper line, and it can't be here because 4, 5, and 6 is eliminated from that because of there. Therefore, it must be here. And it cannot be a 5 here because the 5 has to be one of those two cells. Because in this box, where is the 5 going to be? Can't be here, can't be on any of the lovely lines, so it must be here. So this has to be 4 or 6 here. Similarly, we have a 4, 5, 6 triplet in row 5 or column 5. So this cell cannot be 4, 5, or 6. So we have 1, 2, 3, 7, 8, 9. And now we have, in this box, 6 cells, which have to be 1, 2, 3, 7, 8, 9. Well, the rest of the box then must be 4, 5, or 6. So this is 4, 5, 6, this is 4, 5, 6, and this is 4, 5, or 6. And we should have actually labeled then all the 4, 5s, and 6s. I think. Yeah, we have 3 here, 3 here, 3 here, 3 here, 3 here, 3 here, and 3 here, and then 3 here, and then 3 here. Yep. All the 4, 5, 6s are labeled. Okay, so now with the lovely whisper lines, what I like to do with the lovely whisper lines is just start this, and this applies to German whisper lines and above. So German whisper lines are, the rule set is that the adjacent digits must have a difference of 5 or more. Well, the thing is, if you think about it, this, whatever this is, must contain a 1, 2, 3, or a 7, 8, and 9, right? So it's either low or high. And if you have a 1, 2, 3, those 3 digits can only be next to the digits 7, 8, and 9, right? Because if you take a 1, which is the lowest one, and you add 6 to it, that leaves you 7 and above. So if you have a 1, 2, or 3, it must be next to a 7, 8, 9 on the lovely whisper line, which must be next to a 1, 2, 3 on the lovely whisper line. So you'll always alternate different sets over and over again, right? You'll always go low, high, and then low, high, low, high on a lovely whisper line, or a German whisper line too. Just that the German whisper line, the sets are 1 through 4 and 6 through 9. On the lovely whisper line, it's 1, 2, and 3 on the low, and 7, 8, 9 for the high. So we can start by basically choosing any color, and we just choose that, and we say this is red, this is orange, and we'll make this then yellow. So it always has to alternate then. This has to be orange, this has to be yellow, this has to be orange, this has to be yellow, and these two are yellow because they're next to an orange. This orange means this has to be, sorry, this yellow means this has to be orange. And this has to be orange because it's next to a yellow. This has to be orange because it's next to a yellow. Well, interestingly enough, and this has to be a yellow because it's next to an orange, and this is a yellow because it's next to an orange. Well, in this box, we have 3 cells that are orange and 2 cells that are yellow. If we made the oranges high, the problem is we know we already have a high here because, again, this cage must add up to 18, and it has to have a 7, 8, or 9 there. But then we would have 4 high digits out of 7, 8, and 9, which is only 3 unique digits, so that's not possible. So therefore, the oranges all have to be low, which makes the yellows all high. So and this is also a high. Well, we have a lot of situations where basically we have 3 high or 3 low digits now. In row 2, in row 3, row 4, and this box. So the remaining cells in the box that are in the lovely whisper lines must be low. So these must be low, this must be low, and these 2 must be low. These 3 have to be high, these 3 have to be low. And it fits because this alternates between low, high, low. This must be high, which means this must be low. So this cannot be 8 anymore. This can't be 8 anymore. This has to be a high because it's next to a low number. These 2 have to be high because they're both next to a low number. Therefore, we have 3 highs in row 5, which eliminates highs from the rest of the row. So this can't be 7, 8, 9, and it is a low. These 2 must be next to a low, so this is low and this is high. This must be a low, which must be next to a high. And the remaining digits next to it must be low, which makes this high, and this is a high because it's next to a low. This has to be low, and this is low, as is this. These 2 must be next to highs, so these are all highs then. And we have 3 lows in row 7, which eliminates low from the rest of the row. So these all have to be high. Therefore, this can't be 1, 2, or 3. They must be next to lows, so these are all lows, and therefore this is a high. Well, we have 3 highs now in this box, which eliminates highs from the rest of the box, so this must be a low. So this cannot be 8, and it is a low. Okay, so we have to figure out what these can be. Any digit that can be next to 3 unique digits on a lovely whisper line has to be 1 or 9, depending on if it's low or high. This specific cell is next to 3 unique digits on a lovely whisper lines. So this must be a 1, right? Because this has to be some combination of 7, 8, and 9. This can't be 7 because it's next to 2 unique digits on a lovely whisper line. This can't be 7 because it's next to 2 unique digits on a lovely whisper line. And remember, this has to be 2 or 3 here, right? Because that's all that's remaining. So 7 can never be next to a 2 or a 3 on a lovely whisper line. So this can't be 7. This can't be 7. Well, where is the 7 amongst these 3? It has to be here. So this is a 7. This 2 or 3 can only be next to an 8 or 9 on a lovely whisper line. This is also 8 or 9. These are fine. The 2 or 3 can only be next to an 8 or 9 on a lovely whisper line. Oh, and we have to have... This could be 7, 8, or 9. So what are the possibilities? You can never have 8, 9, 8, 9 here because that already adds up to 17, and we have an additional digit to add up to. It could be 7, 8, and this is 2. It could be... But, okay, if this is 7 and 8, only this could be 7. So if this is 7, 8, this would have to be a 2, and 2 would be next to a 7, but that has a difference of only 5, so that's not allowed. So this cannot be 2, 7, 8. It must be then 1, 7, 9. So this cannot be 2. This has to be a 1. This has to be a 7, and this has to be a 9, which forces this to be 8, which makes this a 9. This then is a 7, because that's the only digit left of the highs. The 8 adds up with 2 digits to add up to 18, so it must be 4 and 6. So this can't be 4 or 6 because they're already taken in that 4, 6 pair. So this must be a 5, which means this can't be 5. Where's a 5 in this box? It can only be here. So this is a 5, which means this can't be 5. Therefore, this is the 5. This can no longer be 5. These can't be 5. Where's the 5 in this box? It has to be here. So this is a 5, which means this can't be 5. Let's see. Where else do we go? This is a 2 or 3. This has to be 8, because that's the only remaining digit left. Or that's a high. The 8 cannot be next to a 3 on a lovely whisper line, so this is a 2, which makes this a 3, which makes this a 2, which makes this a 3. So therefore, this is a 1 to 2 ratio with a 3, so this must be 6, which makes that a 4. This 6 makes that a 4, and that 4 makes that a 6. Therefore, these can't be... This 4 means this can't be 4, so this is 6. And 6 can only be next to 3 in a 1 to 2 ratio, so this is 6. These can't be 6. This can't be 6, and this can't be 3. Oh, again, this has to be a high, right? Because we have 3 lows here. And also, it has to add up to 18 also, which means it's like some combination here. Similarly, again, if this is... this could be 7 or 9 here, though. So this could be 278 or 179. We don't know. So this could be 7, 8, or 9. This is 1 or 2. This is 1 or 2. This can't be 7. So this still could actually be 2. It's either 1, 7, 9 or 2, 7, 8. Either way, you need a 7. So this has to be 7, which makes this not a 7. The 7 can only be next to 1 on a lovely whisper line. So this is 1, which makes this a 2. This then must be a 3, because that's the only digit left. Well, 3 can only be next to a 9 on a lovely whisper line. So this must be 9, which makes this an 8, and therefore this is a 7. This can't be 8 anymore, so this must be 9. the two digits adding up to 12 with 9 is 1 and 2. So this has to be 1 and 2. This has to be a 3. This is next to 2 unique digits on a lovely whisper line, and as is this. So 3 cannot be either of those. This must be 2 then, which makes this 4 to maintain a 1 to 2 ratio. That makes this a 6. This has to be 3 because that's all that's left. 3 is only next to a 9 on a lovely whisper line. This has to be 2, which makes this 1. This has to be 3. Because we need 2 digits on a lovely whisper line, this has to be the 9. This cannot be 7 because it has to be next to 1 and 2 on a lovely whisper line, which means a difference of at least 6. So this has to be 8, which makes this a 7. This can no longer be 1, so this must be 2, which makes that a 1. That's the only possibility for 2. Sorry, this has to be a 2 on this line then. The only digit possible now here is a 7, and 7 has to be next to a 1. So this is 1, and this cage adds up to 12, which is 1, 2, and 9. So this can't be 9 anymore, so this is 8, which forces this again to be 4 and 6. So this is 4, this is not 6, this is not 9, this is 6. This can't be 4, so that makes that a 5, which makes that a 4. This can't be 4 or 6, so this is 5. This can't be 4 or 6, so this is 5, which means this can't be 5. We have a 4-6 pair in this box, which means this has to be a 5. This can no longer be 5, and this can no longer be 5. This can't be 5 or 6 because of these two pairs, these two cells. So this must be 4, which makes this a 6, which makes that a 4, which makes that a 6, which makes that 4, which makes that 6. This can't be 4 or 6, so this is 5. This can't be 6 here, so this must be 4, which makes that a 6. The remaining digits here are 1 and 2. And this digit is next to both of them. So 7 cannot be here because 7 cannot be next to 2 on a lovely whisper line because it's only 5 away. So this must be 8. This must be 7. This has to be a 3, which can only be next to 9 on a lovely whisper line. So this is a 9. And as the only high left in this box, it must be a 7 because we already have 8 and 9 here. 7 can only be next to 1 on a lovely whisper line. So this is 1 and this is 1, which forces this to be 2 as the remaining digits. This can't be 2, so this is 1, which makes that 2. This has to be 3. This can't be 9, so this must be an 8. And this is next to both. Well, can't be 9, so this has to be 8, which makes that a 9. And this is 8. And that's how you solve this puzzle. So you can actually, this is actually very similar to German whisper lines. It's just a little bit, it's actually much more restrictive. So that's why I went through looking for the 4, 5, 6 pairs, right? Or the 4, 5, 6 triplets. Because we knew 4, 5, and 6 could not be on any of the lovely whisper lines. And that makes things quite a bit easier in my opinion. You could also just target, I don't know, I think the way that I did it was probably the easiest. Because again, you have very limited places where you can place the 4, 5, and 6. So that's the reason why I targeted it that way. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.